Harris Majamana doing civil engineering structures. So my project is no longer focused on recycling concrete aggregate. So concrete aggregate is basically when you have a building, then my western to find out which is on Chiro. So what we discovered is we're not using the aggregates that we get from a demolished building before the strength again. So my project was to improve my standard so that we can use them again. So project enhancing recycled concrete aggregate performance by two ways, using pozzanic slurry treatment and cement replacement. So basically, the motivation behind when we have demolished concrete, we want to use the recycled concrete aggregates again. So it's basically sustainability and of course economically advantageous. So the objectives are done. The first was to measure the effect of pozzanic soil replacement. Could it cement? These two materials, pozzanic slurry and fly ash, what is going to be the cement? And of course, what is going to be the effect on strength if we retreat recycled concrete aggregate using slurries made from these two? And the third objective was to characterize, to say what are the characteristics specifically to these materials. In cement replacement must be treatment. So the methodology, first of all, material testing, where we had to perform sieve analysis, RCA preparation. So the BS requires recycled concrete aggregate should have not more than 5% of fines. Ndeti matenga magibs ndiwaphwanya tikawaphwanya timasafer njengo ili mafines ajasakhale about 5%. And then tiwalanga prepare slurry of 40% concentration. So the slurry was either having fly ash or pozzanic soil. So in 1 to 5 by the ratio to water. Ndeti matenga madzi muna 5 kg, ndeti 1 kg tisakaniza. And then we're going to take the recycled concrete aggregate tivika. Tikadzivika zindojia for 4 hours, and then after 4 hours we'll dry them for 2 hours, air dry. So we prepare the mix design for class 20. Immediately a few mix design procedures outlined in the PS. And after preparing the mix design, Tibabanga will replace cement with 0, 10, 20% with varying these inputs. And again, aggregate we had the natural aggregate on the site, and that was our control. And then we had untreated recycled concrete aggregate, or RCA as I'm going to be calling it. And then the RCA retreat in this slurry, fly ash. The rest on the RCA winner, retreat in the slurry, pozzanic soil. So those are the variability. So from the observations, as you can see from this chart, strength, yes, aggregate between the side was very high, because the reached up to 17 neurons per millimeter squares, which is very close to the strength target, which was of 20. Of course, this was high from many recycled concrete aggregate retreat in the pozzanic soil. For my recycled concrete aggregate retreat in the fly ash slurry, the strength went that significant. And again, if you see here, as we are replacing cement in both these two variables, here I've just shown the graph like the outlier in terms of performance, which was also pozzanic soil, of which the increased the strength from 0, 10%, 20%. You can see as the graphs are there. Strength of course not as high as retreating, it was still higher compared to fires. And then durability, which was water absorption. It was also observed from the test. The more we add this, increase percentage of cement, percentage of pozzanic soil. Is very good. That is a very good thing when it comes to durability. And then in the due course of the experiment, we discovered something fascinating, which was good. Increase cement replacement by fly ash strength recycled concrete aggregate retreat tikamuvika musale atumena fokuzeje tikamuvika ndikumuvula ndikumapangano reverse. The effect was now different, as you can see from this graph here. You were because you have reversed this, which was very fascinating. So in terms of recommendations for further studies, I think one billion research on the optimizing time, because for me I was using 4 hours. that wasn't the optimum time. 5 hours or less should be okay. And of course, in terms of durability, they also need to check on surface attack and carbonation. And then finally, there are paufunika panga mago structure analysis imene ufuna pange kuti my interfacial transition zone nathu aja amene panga improve through this tione kuti amapanga improve how, and then what more can you add kuchenga this strength yathu krebwe. The key challenges amene for example sample size the problem is for statistics timafuna tizikhala ndi my variations at least at average, which was a problem. And then in my case, in my bank, I was averaging. And then with time, you will still be able to train. Flash characterization in Avura could characterize that way. So as a result, it might use what we know from literature for characterization. And then durability of the scope, as I said, project is a very big project. For Yantawi, in the end of semester project, I was conflicted with focus on a lot of things. That's why I say there is recommendation for further studies, because this could have been done if we had more time.